to do an evacuated melting point for caffeine. Your textbook leads you to believe that caffeine might start decomposing before its melting point and give a bad result. And another thing that caffeine does is it undergoes what's called sublimation. You remember sublimation is going straight from a solid to a gas? We don't want that. We want to do a melting point. We want to see the solid become a liquid. So I need to prepare a capillary that can be evacuated of air. No air, no combustion, no decomposition. Also, evacuated melting point. Sublimation is prevented because once you melt the substance that sublimes, it will sublime for an instant, create pressure, and then become solid again, and you're no longer near the triple point, which would be required for going for sublimation. Anyway, I misspoke there, but that's okay. Caffeine needs to get in a capillary that I can suck air out of. I've chosen a 9mm pipette, and I just need to seal it here so it looks like a capillary. I just seal like we sealed bells earlier today. And that is now sealed, and it's a little too hot to put caffeine in it, so I prepared another one ahead of time. And I am going to put caffeine, a little less than 1 centimeter in there. Way too much, there we go. So we have a melting point sample, but it's not an evacuated sample yet. It needs to have air sucked out of here. So I'm turning on my pump. It will now be under suction. And I verified that it is sealed, otherwise the caffeine would have just snorted right through the hose. It didn't do that. So now I need to, it's all evacuated, there's no air in here. I need to break it there and seal it. Now earlier today you were stretching glass. Today I'm going to use the same procedure, but I'm going to pull it while it's still in the flame, and that's for stretching and breaking and sealing glass. So here I go. In the hot part, really hot, and pull, and it's broken and sealed. This is a capillary that will work for an evacuated melting point. Later I will take a pair of tweezers so I can grab it here and then put it back in the flame to straighten that out to get it in my machine. And I will do a melting point using this evacuated capillary. And once again, the two reasons we do evacuated is to prevent reaction with oxygen. That's called decomposition or combustion. Creates impurities, lowers the melting point, gives a wider range. We don't want that. Also, prevents sublimation. You don't need to know how. This does two things. It prevents decomposition with reaction of oxygen. It prevents sublimation. Both problems are solved with an evacuated melting point. And that is the end of our video.